Hello and welcome to Module 17, Attacking What We Do. So we're going to look at the different types of attacks that are used using IP. So we'll take a look at the attacks that IP services may have and the different types of enterprise services. So we're looking at the really common different types of attacks and what to do about them too. All right, so the first one we talk about is the ARP. What is the address ARP? What is the address resolution protocol do? Okay. If you remember from your CCNA, let's say AH1 has a packet that is destined to 192.168.1.7. So he's going and he places this packet into a frame, puts his MAC address on it. Now he needs the MAC address of this guy, the .7. So he will send an an ARP request to everyone, broadcast message. Say, hey, whoever has this IP address, 192.168.1.7, please give me your MAC. When everybody receives it, he will respond back with an ARP reply. Now, when he replies, he puts his MAC address in his memory, in cache. I will say in his memory that 192.168.1.7 has the following MAC address. And remember, so he doesn't have to keep requesting it. That's what ARP is. So he puts it on the frame and he'll be able to communicate with them, sending frame, because now he has his MAC address. But the reply is called gratuitous ARP. And what that means is this guy could have sent him a reply without H1 actually asking for it. He could say, hey, 192.168.1.7 has this MAC address, HT's MAC address. And H1 will believe it and put it in his memory. Is that clear? So he doesn't check who is actually responding. He'll just take any response, which is bad, right? And you can use that as an attack. So here is a typical ARP cache poisoning. Let's say this guy wants to get out on the internet, right? So what does he do? He sends out and he requests the MAC address of R1 and he puts it into his memory. Because he gets a broadcast message, this guy knows the MAC address also of the default gateway, right? So what is he going to do? He will send a gratuitous reply without PCA actually requesting it and telling him, hey, MAC address A1, 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 A1 is me. And then what does PCA do? It will say, hey, the 192.168.10.1, which is the default gateway, is this guy MAC address. So now when he wants to get on the internet, he's going to send the data to him. He looks at it and he can send it out to you. You have no idea that this guy is actually getting your data before it goes on the internet. That's what cache poisoning means. Okay? And look, please write this down. These are the different types of utilities that you can use to create this type of attack. DSNF, Cane Enable, ARP, Yercina, and a whole bunch of others. You can see a lot of these in, you can use these and practice them in Kali Linux. All right, let's take a look at some DNS attacks. The DNS has, what does the domain naming services do? You just type in a name and it will resolve and gives you the destination IP address. Well, DNS cache poisoning, what they do is you can, please take a picture of this. You can go in there and falsify the record. So for somebody typing Microsoft.com, you'll just give the wrong IP address, right? Amplification and reflection attacks you can use. So you can actually use that IP address that's in the DNS server to send to many, like we did with the ping amplification and reflection. We'll use the same thing to use that IP address to send many requests to that domain. Resource utilization attack. So you can conceive all the, all the CPU power that the DNS server have, and you won't be able to resolve names for anyone else. Or you may attack the DNS server. That's what I mean by the amplification and reflection, right? Well, this is really attacking the actual DNS server attack. So you can, this server itself. So people trying to use the DNS server won't be able to use it, right? All right. Fast flux. We'll write these down. You may also, threat actors will go into the DNS and change their names very, very quickly because they create domain names and IP addresses so people can go in there and they'll just want to use them temporarily for, to fool people, to steal, or for whatever they want to do, but they want to change the name and the IP address very quickly. That's what fast flux does. It will go into the domain, change the record very quickly. And you can even do double IP, even do it much quicker than that. Change the host name and the IP address. It makes it much more difficult to break, to find out who's actually doing what. Domain generation algorithms. You can also use that to randomly generate domain names. Imagine that. Just create domain names with IP addresses very, very quickly. All right. You may use domain shadowing attacks. Please write these 2 bullet points. So domain shadowing attacks, you can gather domain accounts in order to create subdomains. So let's say you have Microsoft or Cisco.com / and you can create a subdomain so people can go in there and you have, stuff in there. People will think you're going to Cisco.com, but you're really going into the subdomain of that Cisco that I created with an IP address, and you're coming to my server. And of course, I'll have you type in your username and your account information and all that wonderful stuff, right? Remember, the parent domain will be Cisco.com, but the subdomains are located on a malicious server somewhere else. That's called domain shadowing. DNS tunneling. Please write these down too. So what DNS tunneling does is it creates, instead of a DNS request in the record, you have to be able, you can hide data in a DNS request, but it's not really for DNS purposes. So tunneling is really putting data inside a DNS message, an attack, so you can send data to the victim itself. You have to be able to recognize that the data that's inside is non-DNS traffic that's hitting inside the DNS. So when you have DNS traffic, routers, firewalls, and IPSs may let it go, right? Because they say, hey, somebody's requesting an IP address for the following name. But what's inside hiding is a non-DNS traffic. You got to be able to, because they want to circumvent, firewalls and IPS system and sneak into your network. So you want to be able to detect that. You have to be able to inspect. Write this down on the bottom. Make sure you write that down. You have to be able to inspect the traffic, the DNS traffic that's in the packet itself. All right, so let's continue. That's DNS tunneling. DHCP. Well, we all know how the DHCP works. Remember DORA? The client will send a discover. He will send an offer. The client will acknowledge that request, and then will request that offer, and then the server will acknowledge that request, right? So 4-way handshaking. D, discover. O, the offer. R, the request. and A, the acknowledgement, right? You already know how that works. We talked about that previously. All right, well, DHCP spoofing, please write this down if you have all of these, because if you have someone else pretending to be a DHCP server that is closer to you and he gives you the offer and you accept it, he'll be able to give you the wrong default gateway, the wrong DNS server, wrong IP addresses and masks, right? You don't want that, of course. All right. Let's take a look at some enterprise services, HTTP and HTTPS. Okay, so for HTTP, please write these down. If you're going to a wrong website that has malware and you try to download stuff, be very, very careful. So you go to a website that is compromised, there's malware in it, right? The web page, you click on it, you don't even have to download. You go into a different, they may redirect you to a different website where there is codes that you'll download. You have to really click on something that is, you think that you want or you would download, and an exploit kit will be downloaded on your computer. But you have to take action, and you will get a chance not to download and execute those malicious exploit kits or codes. So be very careful which websites you go to, even if it's HTTPS. Okay? So the different types of connection that you are connecting, you'll get codes like informational successful redirection and so on. But to defend web-based, please write these 4 bullet points. Make sure your operating system is updated and browsers with current patches and updates. That's number 1. Hardening your device and your web page and your web browser are the number 1 to really prevent any of these HTTP or HTTPS problems. Use a web proxy to block malicious sites. So make sure that you have some sort of a software that can detect or know which websites to go to and which one not to. McAfee is good with doing that. It will give you either red, yellow, or green, depending on which website to go to. And they'll tell you, hey, these websites are known to have malicious codes. Stay away from them. All right. And it's best, which we will discuss later on, to use the OWASP security practices. We will discuss this down the road this semester. So keep an eye when you are developing applications. Use the best practices of the OWASP. And also, of course, you want to educate the end users. Let them know that, not just go download anything that looks free and you can use. Be very, very careful doing that. So you need to educate the users. HTTP exploit. If the HTML pages that you are downloading, they used iframes, and iframes that allows the browser to load stuff from other web pages. That could be a problem. So you go to a web page, and now web browsers goes to another web page to download stuff for you. That's what the iframes are used for. So please write these down. Okay? All of them. Because you want to know the steps to prevent malicious iframes. Okay, so you need a web proxy, which is really like a web server, anti-malicious. It looks for malicious websites and things like that. Okay, check out if the web developers on the pages that you go to, if you can, if they use iframes or not. Cisco Umbrella does that. So you want to use that. So the Cisco Umbrella may be used to detect if you have malicious iframes. And make sure that you and everyone else understands what iframes are used for. All right? You may use 302 cushioning. So please write down all of these as well. So the 302 found HTTP response status code is directed to the user web page browser to a new location. So 302 is when they send you to a new location in the header. So the browser believes that the new location URL is provided in the header. So the browser is invited to request a new URL. That's what the 302 cushioning means. So you'll be redirected to another web page. Of course, that's not good either. Again, write these down and write down the steps to prevent the HTTP 302 cushioning. You don't want to be redirected to a new web page, right? Again, you may use the Cisco umbrella to prevent this from happening. Domain shadowing, right? We discussed this a little bit earlier. Write this down. So domain shadowing, you may compromise a domain and then create subdomains in it, right? And those subdomains, when you type, for example, cisco.com/blah, blah, blah, you go into that blah, blah, blah website or server that's somewhere else at the attacker end, and you think you're in the Cisco server, but you're not. You're in a subdomain of a different server, right? Again, how do you prevent that? Go through these 4 steps. And the Cisco umbrella does that too. Protects you against domain shadowing. Domain shadowing is having subdomain of some legitimate domain, like cisco.com. Emails. Well, we all know what the different types of email, and you got to have some sort of an email prevention server. So, but anyway, the email attachments. Make sure that, all the attachment, especially don't have .exe files. Don't download any attachment from users that you are not familiar with. Email spoofing. So somebody may send somebody else's address. You think it's coming from eBay, but it's not. They're using their email. Spam email. We know what spam email is, right? A lot of our ISPs will protect against that. Now we have spam calls too. Somebody will get millions and millions of emails, and you can actually pay for it, and they send information to emails to everyone, right? They're coming from all over the place. Relay server. Write this down too. Well, you're writing all the examples of email threats. So please write these 4 bullet points. The email relay server is an SMTP server that allows anybody to send emails to it. Remember, the SMTP server is where you send your emails to, and he's the guy. The SMTP server sends it to the POP server, where it's going to be received on the other end. And if you have an email SMTP server that has the relay server open, that means anybody can send email to it. You don't want that. WEP exposed databases. If you have databases, remember what a database is. It has information about everything that the company has. The users, their names, addresses, products, you name it, right? So, and it could be a web database. So web applications connect to a rational database to access the data. So please write these down. And these rational databases contain sensitive data, like employees, records, products, whatever the database has. But you could actually have code injection. So you can execute some commands on the web application to access these data. Okay, so or SQL is a top of a Microsoft database, so they may place SQL injections to access the SQL database. That's what the SQL injection is. So please write these. At least you need to know the definitions of what the bullet points for code injection, SQL injection, the cross-site scripting. Please write that down as well, and how to prevent XSS attacks. What XSS is, where you have web pages that are executed on the client side. So you went to a web page, they send you a web page, and in that web page there are scripts that has to get executed on your browser when it's been received. And those scripts could be malicious. That's called cross-site scripting. You know, those scripts are on the web page that you got from a web page. It's being executed on your machine, and that could be a problem, right? So how do you prevent that? Ensure that the web application developers are aware of it. You may not know that all the time. IPS system will be able to detect all these web pages that has those scripts and that they are not malicious. Not all codes are malicious, but you don't know, right? Especially if you went to websites or web pages that you're not familiar with, right? And you can use, of course, the Cisco umbrella to do that. All right, so that's it for... All right. And that's it. So that ends the chapter, the module, and I'll see you in the next module.